All right, so this is stream processing with Hazelcast. I'll try to get through my presentation quickly, and we'll get to the code and the demo. So hopefully that'll be interesting. We're here all week. We're one of the sponsors, so stop by our booth to learn more about Hazelcast. Pick up a T-shirt, one of our Speed Matters. We also have stickers, meet the team, learn more about Hazelcast. If you were here earlier, one of my colleagues talked about the in-memory data grid. I'm actually not going to talk about that. I'm going to talk about stream processing, which is actually what the future of Hazelcast is. I'm going to talk a little about digital transformation with Hazelcast, and then I have a demo that I want you to imagine what the future is going to be like with Hazelcast, stream processing, and I think really kind of what the world is going to be like going forward. It already is in a lot of ways. I did want to ask, until today, has anyone ever heard of Hazelcast before? Show of hands, a couple of people. Anybody using it, open source, enterprise at all? Not really? Okay. Hopefully this will be a good introduction, give you an opportunity to check us out, download the software. It is open source. We have the serverless offering as well, so it's got a lot of potential. So this is really about the digital transformation piece. My colleague alluded to it earlier, who was talking about this digital integration hub. Really what it's talking about is the idea that right now when you build a solution, you have all this data that's going from all these different applications and all these databases, and you have to do this exchange of information. Really, that's a lot of I/O, that's a lot of reading and writing back and forth. But with Hazelcast, you can send all that data into Hazelcast and have that provide the basically the storage, for lack of a better term, for where the exchange can happen. So now I want to go into our demo here about stream processing. So the demo is basically about, if you would imagine the Royal College of Physicians in England, they had come up with this, basically this news scoring algorithm for patients. And the idea was that if you had these, originally they did these 6 physiological factors that were to, if you monitored them, you would be able to provide a score as to whether or not a person is in a fair state or they needed more medical attention. Now, they've since expanded that to 8 criteria, and that's what these 8 criteria are. And what we've done is we've taken that a step further and said, well, some of this information currently has to be handwritten, monitored, and it's not necessarily easy to check this information on an ongoing basis. But we imagined if we had devices and we were able to monitor a person and stream that data in, then you would be able to, would be able to monitor a person, and then every instance that their physiological factors changed, then you would be able to get them rapid care to be able to increase healthcare outcomes. And they've proven this out. So to be able to talk about what this demo does is we've taken 8 devices, essentially, software-wise, and we've streamed that data in, and we're using basically Apache Kafka as the message bus to serve that through to Hazelcast. Then Hazelcast takes those basically the CSV files, the data streams from that, and we're able to take all those 8 streams of data and process those into a patient record. So you basically have a device that's attached to multiple patients, stream that data in, process that, we're able to run it through a rules engine, and then push that to a scoring, to be able to produce a score from that, and then push that to a visualization. So we'll see how that shows. We'll show that in a minute here. Again, this is just a demonstration or a picture of the processing pipelines here. And then, so for the code portion, we have these Kafka producers. These basically are the 8 streams. So we have 8 devices. They're creating the 8 Kafka producers from that. Then those feed into our 8 pipelines from there. And then the last pipeline is then sent to the rules engine, which then creates the score for each algorithm, and then puts that out to the scoring engine. So let's get to the demo. I've already started up Kafka, Hazelcast, the Graphite, which is just a time series database that I'm using to capture the output from the rules engine, and then Grafana. And then now I'm going to start the actual application. And while that's running, I'll show you, we had this, like I said, there was the Kafka producers. So this code basically this produce records. It's essentially grabbing the CSV file for each of the devices, which is essentially the CSV data that we had mocked up. And that it's a simple data, but it's all sorted by date timestamp, and then each of those devices. So we've got the consciousness device, the breathing device, the heart device, from that diagram I showed you earlier. And then those all feed into the map data loader. And then this makes the connection to Hazelcast, pulls that in. Now these are the 8 pipelines. So they're all consuming those Kafka producers. And now they're taking those streams, and then they're merging it into, basically they're processing each of those individual streams into a patient record, a patient instance record. And then they send that to the scoring engine, which is a Python. So we've got our Python rules engine file. A colleague talked about an ML inference that we can do. We didn't go down that path of doing machine learning. We figured this was pretty simple to just write a rules engine with Python, so that's how we approached it. So, because the algorithm from the News 2 was pretty straightforward. And then it returns back the result into this pipeline to the, so we've transformed these streams back into the output here the scoring algorithm. And then I can come here and we'll look at Hazelcast Management Center. So I've got my one cluster. I've got all my patient device maps, and then I've got my results. And then in here, I can see my jobs running. This is the risk detector. So this is the, after I've processed all these streams, then now I am getting back the risk detector algorithm from the machine learning. And then here is Grafana, which is now showing me each of the, I have a patient scorecard, and a patient monitoring. Guess I was doing something here. And you can see all the patient IDs that have been, and then it'll show the data here for each of the patients. So, as the processing continues, all this, some of the stuff that says no data will continue to fill in. So you can see here's, for the air oxygen, so this person is on oxygen, so that's why that's red. This person is not alert, so that's why that's red. And then, the rest of the data is being formulated and coming in, so. Okay. And again, the whole purpose of this is that this is all real time. We're just streaming this data in, processing it, and scoring it. We're not saving anything to the database. We're not using in-memory cache. We're not doing anything. We're just using Hazelcast to just basically take in the data, process it, and then output the data to the visualization. So you can just kind of imagine how if you were on a head nurse on a floor, you had this information, you could see how, oh, this person's state has changed. We need to go and administer further care to that person. So, okay. That's essentially, sorry for the technical difficulties, but that's essentially what I was going to present today. So. Any questions? Okay, thank you.